Good morning, guys. So this is page 244 to 245. You only are responsible for numbers 1 through 4. So I'm going to walk you through how to find all of the roots of a polynomial function. Please keep in mind you can use your graphing calculator or Desmos or whatever you're using, because otherwise it's next to impossible to find the imaginary roots. All right, so start with figuring out your possible rational roots. We're going to use our P over Q. And we know we have our don't know what that is. Get out of there. Our what are we looking for? Our factors of the constant. So we're going to have plus and minus. Oh my goodness. All right, plus and minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12 over our factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, honestly, I think at this point you guys should be able to simplify. I'm not going to go through every single possible rational root, but you can go through yourself if it makes you feel better. So now what you're going to do is take the function and put it into your graphing calculator, and let's get some ideas of what our probable roots are. So there it is. I have it on Desmos. So you can see between -1 and -2. So we probably have that fraction, which is -4/3. And then on the right-hand side, 1.5. So let's use synthetic division because that's going to help us find the imaginary roots if there are imaginary roots. And keep in mind, at the end, we should have 4 total roots, okay? All right, so let's start with -4/3 because that's one of the roots. And that comes from just simplifying your possible rational roots from your P over Q. All right, keep that in mind. All right, so our coefficients are 6, -1, -6, -1, and -12. I feel like I'm going to run out of space, but okay, so we're bringing down the 6. 6 times -4/3 is -8. And then we get -9. Whoops. Oh my goodness, this pen is terrible. Then we're going to multiply, we get 12. So then we get 6 here. Again, 6, we know that's going to be -8, which gives us -9. And then that gives us the +12. So we're just showing, okay, we got the remainder of 0. We're good to go. All right, so now we're going to use our current function, and we saw that other 0, right, was at, where was it? At 1.5, which is the same thing as 3 over 2. So 3 over 2, we're going to have 6, -9, 6, -9. And then bring the 6 down. All right, 6 times 3/2 gives us 9. That gives us 0. That gives us 0. 6. There's our 9 again. And there's our 0. Okay, so now we're down to 6x squared plus 6 equals 0. So we know you can do 2 things. You can use the quadratic formula, which, I mean, you can always use the quadratic formula when it's a quadratic, but we can also just use our solve by square root method. So if we subtract the 6, we get 6x squared equals -6. Divide by 6. X squared equals -1. Square root that thing. And we get x equals plus or minus I. So our 4 roots are, and I don't know if I have space, but I'm going to try and squeeze it. Our 4 roots are x equals -4/3, 3/2, oh my goodness, and plus or minus I. Plus or minus I. Okay, so that's number 1. All right, number 2. Okay, once again, we'll do our possible rational roots, and we can continue the P over Q. Okay, so we know we're going to have plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. over plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. It's so much easier if the leading coefficient is 1, but that's okay. All right, so you guys could go through and break up each fraction, but since we're using the graphing calculator, let's just save time and our sanity. Let's go to Desmos, my second function, 6x squared, or to the 6x cubed plus 19x squared. Okay, so we see the 3 here, so we know negative 3.5 is a probable, most definite root, but we're going to show it and make sure we get a remainder of 0. Negative 0.667, and then you can see the 1, 0. Okay, so back to synthetic division. Use the easiest root. So start with 1. Just makes the most sense. Our coefficients are 6, 19, negative 11, and negative 14. Bring down the 6. We get 6. We get 25. We get 25. We get 14. 14, and there's our 0. So then this leaves us with 6x squared plus 25x plus 14. Okay, so we could use that other probable root to do synthetic division again. You could use the quadratic formula, which why don't I just practice that? So we'll have negative 25 plus or minus the square root of b squared, so 25 squared minus 4 times a times c all over 2a is 12. And remember, you could also factor this. It might take a lot of guessing and checking, so this way will always work. So at the end, you should, and I forgot my calculator. I'm not at my house right now, trying to keep it quiet. So at the end, it should all simplify. We already know we had x equals 1. When you simplify your quadratic, it should simplify to negative 2/3 and negative 7/2. Okay, 3 roots, cubic function. Looks like we're good to go. Number 3, let's take a look at that one. So it's 3x to the 4th. I'll do my rational. Let's do the possible roots first. So we get plus or minus 1, plus or minus 3, plus or minus 9 over plus or minus 1, plus or minus 3, which is nice. A lot less possible roots. Okay, so here's our third one. So 3x to the 4th, got 4 roots, looks good. Looks like 3, 0 is a root, so that's going to be nice for synthetic. And then we don't know what that is because it's not a nice rational number. We know that's negative 1/3, and then whatever that is. So that's why we have to use the synthetic, factor all the way, so we can see exactly what those roots are. All right, so let's use the 3, because we know that was a root, and we're going to have 3, negative 8, oh my goodness, negative 12, 24, and 9. We get 3, we get 9, we get 1, we get negative 9, negative 27, negative 3, negative 9, which brings us to a remainder of 0. And then we knew that the other factor was negative 1/3, which you can see from your possible rational roots. So, and we're only at a cubic function, so we have to do synthetic again. So we got negative 1/3, we get 3, 1, negative 9, negative 3, and there we go, bring down the 3, so 3 and negative 1/3 gives us negative 1, gives us 0, 0, negative 9, that gives us 3, remainder of 0. So we're at 3x squared minus 9 equals 0 from there, right? All right, it's just we can just use square roots, we don't have to use the quadratic. So we'll get 3x squared equals 9, divide by 3, we get x squared equals 3, so x equals plus or minus square root of 3, and if you put it in the calculator, you should see that it's 1.732 and negative 1.732. Okay, so that's number 3. Number 4, last one, because you don't have to do numbers 5 through 8. I'll explain that in just a minute, but over here, let's do our P over Q. This one's going to be nice and quick. Plus or minus 1 plus or minus 2 over plus or minus 1 plus or minus 3. And then let's go to our graphing calculator. Looks like this. Okay, so we know it's a cubic, so that means we only see one root, which tells us that we are going to have 2 additional roots, and they have to be imaginary since we don't see them on the axis, okay? We know negative 0.333 is negative 1/3. So let's start dividing. Negative 1/3. So we have 3, negative 2, 5, and 2. Haven't needed any placeholders, which is nice. All right, that's negative 1, negative 3. That gives us 1. Then we get 6. Negative 1/3 times 6 is negative 2. There's our remainder. Okay, so we're left with 3x to the second minus 3x plus 6 equals 0. Okay, so we already know it's imaginary, so we're going to have to use the quadratic formula. So negative b, so it's going to be 3, positive 3, right, because it's negative, plus or minus the square root of b squared. So I'm just going to square it and get my 9, minus 4 times a times c, all over 2 times a, which is going to be 6. Okay, so 3 plus or minus 9 minus, all right, 12 times 6 is 72, right? And then, what did I do wrong? 4 times 3 is 12 times a. Oh, we could have factored out a 3. Let's do that. That'll make our life a lot easier. I didn't see that. Let's do that now. It won't make these numbers so huge. Okay. So we're going to factor out a 3. We get x squared minus x plus 2 equals 0. Okay, so let's do this again. So negative b, so it's going to be positive 1 plus or minus square root b squared minus 4 times a times c all over 2a, which is 1 plus or minus. So 1 minus 8 gives us negative 7 over 2. We can bring out the I, if you remember from Algebra 1a, or, oh my goodness, not 1a, from Algebra 2. So 1 plus or minus I radical 7, it's an I, over 2. You can leave your roots just like that. So we know all of our roots are negative 1/3, and then if you want to break it up, you can, like in the answer key, if you took a look at Mark Sparks, he broke it up. I'm okay with just leaving it like that, so I'm just going to rewrite it. Like, now I just figured it out. Okay? Now, number 5 is a good example. This is just a review of everything. It's looking at the graph and basically analyzing it, figuring out the C, which we've done before, figuring out that there's most likely there are imaginary roots because it's a cubic function, but you're not actually finding the roots for that one. And please keep in mind the Descartes theorem with the positive, negative, 0, and figuring out those possible roots. It's not going to be tested. I spoke to Mrs. White, and she said you won't need it for calculus next year. So we're trying to get through, kind of try and keep it simple for you guys. If you have any questions, please email me. I will hopefully get back to you as soon as possible. If not, I'm always available between 8 and 12. All right, have a great day.